So to simplify my research, we look at machine tools that produce things. So in a car, the engine, for example, or the compressor in your fridge. And to produce something, they need to move. And now if there's a temperature change, the whole machine deforms, and then our part does not look like how it's supposed to be. And if they're a little bit made wrong, they're less efficient during their use. And now we try to make them more precise, that are more energy efficient during their use and more energy efficient during their manufacturing. And now instead of cooling the machine, we want to compensate this with intelligence instead of energy. So I'm Sebastian Lang. I'm a research associate at Inspire and a PhD student at ETH. So in my research, I both work with the machine physically, but also with the digital twin of the machine. So I have the machine physically moving, and then I want to also simulate the behavior. I want to make a simulation before a machine is even built. And this is very interesting, but also very challenging. Making simulations can also be very enriching because we get to learn a lot about the machine without actually having to be there. I think the emotional side of my work is then really in the collaboration. If we work together with an industry partner, you would think it's a technical problem, but there's also a lot of social components to it. You have to convince a team of what is your problem and that your solution might work. What I enjoy most is, I think, working together with students and really seeing them develop during their thesis. That in the beginning they're quite uncertain, they don't know what to do, they're a bit scared usually. Then at the end you really see how they have changed, how they become a more experienced person and how they are now confident to tackle the challenges and feel also more ready to in the end work in industry or work in academia in a real job and not just studying.